again here. We're ready to get started with today's webinar on 3D technical illustrations. But before we jump into the webinar, let me quickly go through our housekeeping rules. The standard webinar housekeeping rules. All attendees are muted for the duration of the webinar. If you should experience any technical illustrations or technical issues, use the little questions window to communicate. And we have some handouts available in the handout sections of the control panel. You can just drag and drop those PDFs to your desktop. And we invite you to do that. We also encourage you to post any questions during the webinar as they pop into your mind. Feel free to post those as you think of them, and then of course we'll answer all those questions at the end of our webinar. For those of you who are not familiar with Larson Software, we're based in Houston, Texas. We've been around since 1984. We've been known as graphics technology experts for over 30 years. We develop powerful, innovative graphics software toolkits based on open standards for 2D and 3D graphics. From the very beginning of the use of CGM, we've promoted CGM with a free CGM and TIFF viewer, but we've recently replaced that with subscription version you can buy on our store. We're a developer of the first HTML5 CGM viewer to eliminate the need for plugins. We're a member of the CGM Open Foundation that maintains the CGM standard. Larson's technology simplifies graphic workflow for technical publication professionals, technical authors, engineers, and those working with 2D and 3D graphics data. So with that said, we'll now turn it over to David Manick for the main part of our presentation.
Thank you, Don, and good day, everybody. Thanks for joining us. Yeah, we speak in the introduction about Larson and our kind of past history in CGM, obviously 2D. We have also doing a lot of work around SVG and another 2D format. But as you can see from today's presentation, we are also very much into 3D and how we deliver 3D technical illustrations now and in the future. So we feel this is an important topic, and we've done a lot of work over the past couple of years on these products that we'll show you today. We'll talk a bit give you an overview of where we feel the industry is going, and is actually, we think it's now viable, very viable to deliver 3D to the customer in different ways. So anyway, let's get on. So as I just mentioned, traditionally 2D format is the normal for delivering illustrations, and probably will be the majority of illustrations for some time in the future. It will be still 2D because there's a lot of legacy illustrations out there. But I think now we really have a great opportunity to deliver 3D illustrations and be more immersive and interactive with the user. So there are certain steps you're going to need to go through to create these illustrations. And some of them you're probably already doing by sourcing 3D data to create 2D illustrations. So there's now a good access to CAD models and reusing those in some way, either as 2D or as we will speak about today, as 3D illustrations. So I'll be giving demos. The first one will be VizEx Edit 3D, which is kind of our authoring package. And then we have VizEx View 3D, which is really the companion product. It's not a standalone product. We'll talk about that later on. It's more of an SDK, a software developer kit. So it really enables, say, a vendor to build in this technology into their solution, say for an electronic manual, an IETM, to view these 3D models. So some of the topics we're going to go through, we'll look through the process, what process we're going to do or need, what tools we're going to need to actually generate these 3D illustrations and deliver them. Something as a brief overview of the source data that we might be looking to use. Native format I'll speak about at that time, but it's a native format for our own software. And then we'll do authoring 3D data and demo that live. Then we'll move on to displaying those illustrations, what technology we're going to have to use, what file formats we're looking at to deliver that data. Then we'll very briefly look at S1000D and 3D content and some of the guidance that they provide. And then we'll look at some of the 3D viewer requirements and give you a live demo of VizEx View 3D. Quick summary and then a Q&A. So as Don mentioned, please post your questions as they occur to you, and then we'll look at them at the end. So the process is quite straightforward. This is probably more around S1000D, but the CSDB could be any database where you're actually managing your illustrations. And IETMs or electronic manuals are kind of pervasive in all types of industries. So our source data would usually come from CAD data, and then we would author this in 3D. So the top line, we're now looking at 3D, the bottom line is 2D. So you could use 3D CAD data to create 2D information, or as we're going to look at today, is 3D illustrations. So you're going to need to author these in some way to add interactivity, annotations, just adding value to them. And then you're going to choose the format that you want to save it in or archive it in. You might want to store that in a database. CSDB would be the S1000D common source database. And then from there, you would usually build your IETM with the graphics and text. And then finally, we'd move into the viewer, where the viewer would be integrated into the IETM, either a 3D or 2D viewer, or both viewers could be integrated at the same time. So source data, probably the audience, most of the audience is aware of CAD data, and there's two main open formats that we support within our technology, IGES and STEP. STEP is probably more common now, and is a really good format for bringing in the models, 3D models, and working with them. We recommend the open formats. It's just usually a lot easier to get hold of. We did look at supporting native CAD formats, but that doesn't seem to have been a requirement by many companies at the moment. So we will look at that in the future if it's needed. But STEP is really easy to get, and most companies will be able to give you or CAD departments be able to give you a STEP file. I mentioned a native format. So one of the things we discovered early on is that we needed a format really within our own technology to actually save the work that we were doing. So although we can bring in IGES and STEP, they're not really suitable to save back the information that we're doing in an electronic illustration. So say you had some animation that you wanted to save, then you can't really save it back into STEP or IGES. So we needed a 3D format to actually do that. So this isn't designed to display or deploy. It's merely as an archive format, so the illustrator can go or author can go back to it and reopen it and be at the same state they were before. So it's really just to save it out and then go back to it later on. So more of an archive format than a delivery or display format. It's also, we built in some optimization to it as well, so it really reduces the file size of the original. So it gave us that opportunity. So what type of illustrations would we want to probably create in 3D as we do in 2D? So generally, the manual would contain exploded spare parts illustrations and assembly and disassembly illustrations. They're probably the most common. But then you would have like maintenance type illustrations, repair, overhaul illustrations, operating and instructional illustrations, which they might call for transparency or a cutaway or some kind of functional illustrations that show how things work. So there are many types, but I think all of them lend themselves to be delivered in 3D. And we'll look at some of those today. So more specifically, illustrated parts illustrations. We've all probably seen these, and we know that usually you have a graphic and a parts list associated with that. Also, you might want to have tooltips to identify parts, interactivity, so we have some link between the graphic and the text. And you need that kind of ability within the illustration to do that linking. Annotations, including leader lines. Do we really need them now if we have an interactive table? We have the opportunity to still add them, but you could still probably do without them in some way if you have a tooltip and you also have the table live next to you as well. So we'll demonstrate that. So 3D is perfectly good now for delivering illustrated parts illustrations. The next type more commonly used, again, is procedural type illustration. So something where you would step through a procedure. And this way you would really have an animation to help you go through that. So you click step 1 and the animation is triggered and it's removed or attached. And there's some kind of link between the text and the graphic. So not completely driven by the graphic itself, more likely to be driven by a text element. So step 1, step 2. You'd also probably like to be able to change the camera angle in some way so you can view it in a different viewpoint. Again, this happens in 2D, but you have 2 separate illustrations to do that usually. In the 3D, you could just click the link and it will actually just zoom in or out or change the orientation of the 3D model. So we could change the zoom factor, perhaps want to fade parts out, visibility if required, to give you more screen room, and also identify those parts quickly and easily, as with the illustrated parts data. So 3D technical illustration really has some software requirements that need to be taken care of for it to be effective. So the ability to import those source formats like IGES and STEP, very easily manipulate those. So we don't need to go into any kind of CAD world where there's a lot of extraneous tools that we don't really need. So we want to make that easy as possible to get the view that we need as quickly as possible. The ability to create animations and put steps into those animations if you're going to link to procedures. Add annotations still. And I mentioned placarded text. That's where the text is not really 3D, that it keeps facing you. We can demonstrate that. Add interactivity and hyperlinks. Change the color and transparency of a component to highlight it in some way. Section the model if we have a cutaway type illustration. So all these things are relevant to technical illustration, and we can still do these in the 3D world. So I'm just going to move on to the demo. This is a live demo. And what I've done here is I've already opened up a step file. I've just done this for expediency. It only takes about 20 or 30 seconds to open. But just to kind of speed things up, I'd opened it already. And this is the whole engine. And I've used this before, so people who've probably watched our webinars before have seen this particular item. But the reason I like it is, well, one, it's not restrained in any way by any kind of it's not proprietary or to a particular company or anything like that. It's just in the public domain, but it does show that you can have parts and also assemblies and sub-assemblies that we can work with. At the top here, we have our toolbar. So the first one is File. So this is where I would say import our IGES file, or step file. We can import other formats as well. So that's where I initially bring that in. And then I did say save, and this is where I could save this as our VX 3D format. So this is where if I wanted to save it in a particular state, that I can do that very easily using this particular format. So import was the way that I got this step file into here. And you can see that we have the whole of the model tree. So the thing is with the model tree, it gives us really the breakdown that comes from the CAD system. So if I've got a sub-assembly, say for instance, if I move this around here, I know that the turbo here, you can see I've clicked on it, but it now shows me that particular component that I clicked on. But above that, we have the whole of that particular turbo. So it's very easy kind of to highlight that, and then I could work with it by right-clicking, and I can isolate this and just take it into its own window and work with it on its own. So from the whole model to a sub-assembly takes really minutes to actually, or seconds to do that. And now we have some tools up here. So tools, we can explode this, we can show it in different states, shaded in this case, or the wireframe. So I can quickly go between these different views. And we've also got a view to actually orientate it into the isometric automatically, so I can just go around and get it into the view that I want, and it'll just keep going round until I get the view I'm looking for, which is this one. So very quickly you can orientate it, and I can even choose HLR, which is hidden line removal, so I can preview what it would look like as a 2D illustration in here. So we can also go to 2D from VizEx Edit 3D, but we're going to focus on 3D today. So one of the illustrations that we mentioned about was something where it was more instructional, or something that explained something. So if I right click on the flange here and go to modify, I can change the transparency of that particular item. So I can just, with the slider, I can really control the transparency, and then if I just clear that selection, I can begin to see through the item. So it kind of gives you like a ghosted type of effect. And say the intake here, I can do the same thing with. I can modify the transparency, and then I can begin to see through what we have here. So you can still see hopefully you can in the webinar anyway. You can see the propeller type arrangement there through the flange. So this could be really good in an instructional environment. So I can save this now as a 3D file, and we'll talk about this in more detail later on with the viewer. But if I go to File and Export, then I can export this as a GLB file, which is a part of GLTF, which is a 3D open format, which we'll talk about in our viewer later on. And then I can view that inside a web environment straight away, very quickly. So that's just to quickly take you through how you would create something like that. We also have the ability to export as a 2D as well, so you could actually save this out as a JPEG if you wanted to as well, if you wanted just a flat view of it. Okay, so I'm just going to, let me just remove this transparency. So if you just re-click on it, modify, I can remove the transparency. And the same applies here. And I also could have actually saved this as a VizEx 3D file as well, and saved it in this particular state. So the other option we have up here is sections. So this really gives you the ability to create a section through an illustration. So in this case here, you can see that I could create a section illustration of this of the turbo. So I can drag the section down or up or out. And then after I've done that, I can again save that as a GLB file and again view that in a 3D environment. So this might be more in the instructional to show how something works, what it looks like inside. And I could also go to 2D with us as well and create a section illustration. So those are kind of two of the kind of other types of illustration, probably not as common as what we're going to move on to, but we really give you that option to do 3D sections and transparencies. Okay, so I'm just going to take that off. And I'm going to reform the whole model again. So I can show all, so I can get back to that state that I was originally. And I'm going to go to another part or another subassembly on this. I think it's here. Let's just, yeah, I'm going to go to this one. And we'll select it and again isolate this off. So this is just a small part, but it's got a few elements to it. I think this will be a good example to show you to do the exploded view. Okay, so let's just make that a bit smaller. So you'll notice here that I've got automatic explode, or I can do this manually. So now I'm in the exploded mode. If I click on this particular part, I can move that away. And there's actually a circlip at the front here. I can move that away. And then I think there's one at the back. Okay, and move that. So, and it's constraining it to the axis as well. Now, here these are bearings, but they're actually created with all separate parts. But that's probably not how I'd want to move them. So, because I would have the actual balls themselves and the sleeves and so forth. So I want to move them together. So what I can do is just get to the upper hierarchy here, and now I can move them all as one back along the axis. And I could do the same with this one here. Oh, sorry, it's the one below it. Let's just move that away. You can see there's another little clip there as well. Okay, so very quickly, I've now created an exploded view of this particular item. One of the new things we've just put in, and this will work in 3D as well, is location lines. So if you want to see how that was kind of pulled apart, we've now added this new feature called location lines. You can toggle that off and on. So again, a bit more traditional, like an illustration would look like, and that works in the if we projected this to 2D to CGM, that would appear as well, but it also works in the 3D. So the other thing I wanted to show you here was that the ability to add an annotation. So if I right click on the circlip and annotation and add, I can now drag out an annotation for this particular part. So we might want to give it a name and a number. And this is the color of the text, and this is the background. So you can actually change these, and we can choose to display this ID and OK, and it will add it to the illustration here. And we can keep going along, and we can annotate this up. And these would appear in the 3D. So if I, let's just select another one. So just click on it, right click, add annotation, and then click and drag out. We can add then, let's just call that bearing. I might want to change the color. And I might want to add number 2. Okay, so We feel that the annotations still are applicable to, say, spare parts, so we added that option in. But they also could be used in a different way. So if I just go, I've got an example here of where they might be used as warnings and cautions and given the particular color. And if I move this around now, you can see that when I was talking about the text, that the text doesn't move in 3D, it stays facing you. And that's really important because if I go all the way around on the opposite side, it will be reversed out. So, and this is one of the reasons we chose this particular 3D format, because it allows this called placarding of text to actually view it. It always faces you, no matter where the 3D goes. Okay, so that's a bit about 3D, exploded views. And I'm going to move on to kind of procedural type illustrations. And we've been working hard to add a animation part to our software. And we wanted to make that as easy to use as possible. So I'm going to create a new animation. So I'm still using VizEx Edit 3D. So everything is built into this version that you're seeing. This is a GLB file. And I'm using this, it's not a very technical type product, but I thought it's something we use later on. So I think it's a good example. So as soon as I create the new animation, you can see that there's a timeline added down at the bottom here. If I now click on the part that I want to explode, or sorry, this will be a disassembly, I've got the option now to move this along this axis and remove it from the punch. Now the timeline is active and that part has been added, and now I can apply that. So now that animation is done. So if I just move it back, I can use the bar there just to move it back, and then I can play it. And that's our first animation we've done really, really quickly. And now I want to remove the second rod and move that away and apply. And you'll notice here that it's added it, we've made it kind of intelligent, that it thinks that, yeah, I've done the first one, but now this would follow on from it, so it's going to start it at the end of this one. That doesn't mean to say we can't redo these after, so we can actually drag these bars out and make the time that it takes to explode quicker or slower, so we have that ability. So I can rewound, I've got some controls at the top, so I can rewind this and then play it. So you'll see it'll come out a bit slower now because it's taking longer, and then the second bar then comes out. And now I'm going to remove the handle, but this time I'm going to go vertically. Again, it adds it to here, and I can apply that. But what I want to do at this point is, I don't want this to be on the screen anymore, because it's going to interfere with these two rods here when they're exploding. So what I could do is say I want to fade the visibility of this out. So when we pull back now and play this from this point, it goes up and then it'll fade away. And now we can explode the other two parts. So with these two rods here, I can actually explode them. I can shift click, as you would usually do in a graphics program, and select both of them and take them both at the same time. So now they'll actually move together, and apply that. And again, you'll understand what's going to happen. It's just going to go at both at the same time. I won't just play that back now. But I wanted to show some of the things that we've had it added in that might be helpful. Is that, say this one has some kind of heat problem, or we need to warn somebody about it, then I can actually change its color. I'm going to change it to red to highlight it and apply. So now it's going to not only explode, but also then it will change its color. And I also might want it to zoom in just to highlight it more. So I might want to zoom in at this point. So I can add a a camera to this. So, and now I zoom in and apply that. So it's now applied that zoom factor into here. So let's just kind of play that back and see the sequence. So it turns red and it zooms in. So all this authoring that I'm doing here would then work in the viewer. So the user could interact with this or just play a button and it will play them back for them. With a camera, I can also add another feature here where I might want to move it underneath to show where that actually came from and apply. So again, this is obviously getting a bit more convoluted, but I move it back, it zooms in, and then it turns underneath so we can look at it. And this is where we really begin to see what 3D could do for us, is that we can see underneath. We wouldn't need a separate illustration to show that. It's just all in the one. So that's the animation side. Hopefully you see how easy it was for me to create that. And we could have done that with parts of the engine and so forth. We could create that procedural type illustration, having steps and so forth, and I'll begin to show that in the viewer. So let's just go back to the slides. Okay, hopefully you can see that. Okay, so displaying the illustrations. So we've been authoring them. We've created the illustration for the ITM or the electronic manual, but then how do we display that? And one of the first things we came across is like, what file format should we use? We didn't want to support everything because it would be difficult to do that. So we had to come up really with a 3D format that would be good to display this information, and fulfill all our requirements. Like IGES and STEP are not really suitable for this. You can get CAD viewers that can view STEP and IGES files, but not really do what we want it to do. So we wanted something with wide file formats, industry support. That was one of the criteria. Easy to implement in a web browser. Supports animation, we've just seen. Small file size without sacrificing quality. The ability to add metadata like interactivity and hotspots and tooltips, and that support for annotations that I just mentioned a minute ago. So it feels like it only took us a second to decide, but it took us a lot longer than that. And in the end, we went with GLTF and GLB. They are the same format, but GLB is a binary format, so everything is in the one file. That's one you would probably use more than any other. Yeah, as it says there, it's a binary blob. It really contained everything we needed. There was no plugin required in a web browser. So, it's native, really efficient loading the models. You could load a model and look at it on an iPad so it really cross-platform. It really optimizes the 3D file size, and also well supported by Microsoft and Adobe, which is important. We wanted something that had a good future with wide industry support. I'm just going to move over this. So this is just PowerPoint, a blank slide, and just to show you that Microsoft do support it. If I go to 3D models and from this device and insert, I can insert that file into here, straight into PowerPoint, and it works as a 3D model in PowerPoint. And the same could be Word, it could be Excel, whatever really Office product you have, they support this. So you can see when I bring the file through, it gives you the views at the top. So that was one of the main reasons that we chose this, because of it did everything we wanted it to do, plus it had this support from the big vendors. So viewing that file, so we there are kind of off-the-shelf viewers, but we really need something that really would work with an IETM and have all the functionality that you would expect from a 2D file in a 3D file. So we developed our own technology called VizEx View 3D, and really, it's just has everything we need. And we've created this software development kit that really makes it easy for vendors to actually integrate into their technology. And all the support for interactivity was there. We can link it to XML, the support for annotations. So we created this SDK, software development kit, to integrate this technology into ITMs or electronic manuals or just into a website in general. So I said I would touch on S1000D. If you look at the latest issue of the spec, there is a chapter on 3D. It is more of a guideline than it is kind of stipulating what you do, or there are certain guidelines in there, and we've tried to actually follow those as close as you can from a viewing point of view. There is no 3D format defined within the spec. I think that might come, but it's certainly not imminent. So, but I would say if you do choose to use 3D, then I would always recommend use an open format. Don't use anything proprietary. So there's some good guidelines in there, but they are mainly guidelines how to use 3D. And we've used those guidelines to develop our viewer and try to follow as closely as possible what they say would be good practice for actually a viewer in 3D within that environment. So, and that's how we've really developed the technology that I'm about to show you. So, got to be capable of interactivity, still displaying annotations, warnings, cautions, and really easy to use with the toolbar for fast display of 3D data. So this time I'm going to go to the web browser. And if you decide to evaluate VizEx View 3D, we have a kind of a microsite where you can just log in. There's no time constraints. We give you examples. If you're a programmer, you'll understand API like a application program interface. We give you a getting started guide. So everything you need to know to implement what I'm about to show is in that guide. What I can do is this is just like a basic viewer. These are some of the controls that I have. I can choose to open a file. So this is that annotation file I opened earlier on, but now it's in the viewing environment. And you can see again the placarded text works in here really easily. You can see the speed, hopefully. I know we're on a webinar, but hope you can see the speed that we move at in here. There's obviously an exploded view with annotations. So all I did was then open the file. That just gives me the open. I can see the hierarchy. So the bill of materials on here of this particular object. So these are all optional. You would probably only implement a few of these actually in the IETM. So the controls themselves, they can also sit outside the viewer window, and you could put your own graphics. So you can brand it however you want. You know, if you've already got a common theme for magnifying glasses or whatever views, then you can really brand this however you want. But it could also reside outside of the viewing window, and also you can implement playback, so you could play this back, all of it for the viewer, or sorry, for the end user, and we can zoom in and out using the scroll bar, and you can rewind that as well. So there's lots of controls you can implement within the viewer. What you decide to give the end user is really up to you and the project. So we more see it implemented like this, where there's a bit more constraint around how the user interacts with the information or the 3D. So I mentioned illustrated parts data. So as we move over, you can see we have a tooltip. It's also highlighting on the right and the table as we hover over the part number, and also obviously description and so forth. And we get the tooltip as well. So if I click, it highlights it as well. So this is an XML on the right. It's not a fully fledged IETM. It's just really an example we give you as part of the evaluation. And it also works in the opposite direction. So I click on here and it gives me number 5 and highlights it. It's actually in yellow here. But it is 3D. So, and with any illustration, if it's complex, there could be different sheets to this. So sheet 1 and the table updates automatically. So everything you might see on a 2D spare parts list is now easily done with 3D. And sheet 2, again, the table updates, tooltips, highlighting. So it's all very much done by XML and now a 3D graphic could be implemented in your IETM. The final one really is more of a procedural type illustration. So you probably wouldn't have any of these tools up here. But what you would do is have your procedural list over this side. And we go back to the paper punch where we did the animations, but here we have, I've already played that animation. Let me just refresh this. Okay, let's play step 1. So step 1, expose the bar out. Now I've decided, I'm going to do step 3, and it sends up a warning that you haven't played the previous animation, the preceding animation yet, or the previous step. So it just kind of warns me that I should really do step 2. Obviously step 3. Let's pick it down a bit slower. Step 4. And step 5. So slightly different animation and explosion, but we can really control that within the authoring environment. So I think this is, again, we're orientated in this view, but I could actually move it around and then we could look underneath, see if there's anything interesting there that would help me if I'm actually disassembling this. So this is, I think, a good example of you could use the most common probably types of illustrations in illustrated parts catalog in a procedural mode in 3D, and probably just as easily as 2. Okay, so let me just go back to the slides. That kind of ends the live demo. And I'll just go back to, and just summarize with the 3D viewing software. So really we need to have the ability to easily interact with the model. We probably need some preset views like isometric. We need to interact with that 3D model and text, like through the steps or through the parts list table. We need to be able to view those animations and play them back in different ways, or have them controlled by the text, by the XML that triggers events. We need to be able to still display annotations in a traditional way. We might want transparent illustrations for more kind of functional type illustrations, and same with cutaway as well. So you can see now that all those 3D types, all those illustration types we could use in 3D within the viewing environment and deliver to the customer. So both products you can evaluate. You can send an email to me and request that, or you could do it through our website. So you can evaluate VizEx Edit 3D, and we can also evaluate the View 3D through the website. We just can give you the link to access that. We'd love to have you on board and looking at the products. So just to summarize, 3D data exchange really should be straightforward through formats such as STEP and IGES. If you're going to display these, then you need to consider file size and how big they are, what space they're taking up, and hopefully we cater for that. You really need to be compatible with the web, with any viewing environment, and really need to question if you're going to use something, does it fulfill all the requirements you're going to need for technical publications? We definitely recommend GLTF as a 3D file format. We've worked with it now for over 2 years, and it's really proved to be probably a really good choice, I think. And also, obviously, Adobe and Microsoft are using it as well. It was a good call. We created our own format, and like I say, but that's only really for saving files. It's not really for deploying. And our kind of objective always is to be interoperable with 3D data now. So you can move it around with open formats very easily into different environments. And we're going to continue down this route. We're not going to neglect 2D. We still have VizEx Edit. Well, we don't call it 2D, but the VizEx Edit standard version, which will continue to actually develop alongside the 3D side. But it's nice now you have the options, both the options from Larson. So thanks for your attention. Let's just have a look. If you have any questions, then there is a few. I'll bring Don back up at this point. You might have looked at them already. So I think the first, sorry, Don. I noticed the leader lines overrun onto the annotations. Okay. Yeah, we'll take a look at that. I think I know what you're talking about, so we'll definitely have a look at that. Yeah, the other question here is about the identifier. You can have one. I think you can have more than one character, Don. Is that right?
Yes.
Yeah.
It will take multiple characters for.
Okay. Disassembly of the whole. Do we just reference to exploded animation of the punch so that the link in each step will show the item on the illustration being exploded? Yeah. So the way that I did it, you probably do it differently. And I did it really for the time wise of the demo, but you would probably create a sequence of animations that then would link to the steps in the procedure. So it would still only be one file, but each file would be sequenced. So that would enable the XML to call out the different steps. So it would, but it kind of wouldn't be one, and it'd be like separate animations for each step, but it would still be one file. Good question. Thank you. Can I reconfirm how faded out and can this be retrieved? Yeah, it can be retrieved. It's just a function. It can be deleted at any time. You don't have to. Anything on that timeline can be removed. So it's just an option within the transform to actually fade an item out. So we can go through that. If this particular question, if the person asking it wants to come through to us, we can go through that with them with a personal demo if it's a bit unclear. So that's an offer to anybody attending today. If you need a more detailed demo, obviously within a webinar, there's only a certain amount of time that we have. Yeah, how do you link 3D S1000D to DMs? Yeah, so that is done. It's within the file format, the GLB format, file format. There are identifiers as there would be in CGM, and we have one of the vendors that we work with, Raytheon, has already done this with XML. So they've linked the 3D to the XML, and it works within their IETM technology. So basically, as with the hotspots in the CGM, it's a similar thing within the 3D file that enables them to do the linking with the XML. So a very similar idea, and that's what we've tried to do with the 3D is try and keep the S1000D standard in mind, where because it's obviously a good one to follow, and keep it similar in the way that you interact with a graphic from the text. So it's not a very kind of, the best thing I would say is evaluate, go to the evaluation, we'll give you an elevation, and then you can actually look at the file and see how the linking is done. Okay. I think that's it for questions. Thanks for those questions. Very good. Thank you. So I'd just like to, can we create shortcut keys? That's a good question. Are there some shortcuts done in the software at the moment?
I was just trying to think.
I don't think there are. I've not really found that I needed any, but we could certainly look at putting shortcuts in if that's
Yeah.
a requirement. It'd be quite straightforward to do, wouldn't it?
Yeah, that's right. I mean, there are some, I mean, like the shift key is
Yeah.
one of the keys. I was trying to think of some of the others. But yeah, we'd have to look at, certainly we could add shortcuts if there's something that's done a lot that it's repeated a lot and that would save time, that would certainly worth be adding.
Yeah, we kind of give there was an overview today, but there are some, we can actually copy and paste within, I forgot to show that, but within when working with the 3D model, you can actually copy and paste model parts as well. So if they only occur once, but you need, from an illustration point of view, multiple copies of that part, they can actually copy and paste into the model tree as well. So that would be just the copy, Command C, Command V, or right click. So, but definitely we could look at that if that's a requirement. So thanks everybody. Great to have you attending today. We have recorded the session. We will post it. So if you had any colleagues that want to watch it, then you can send them the link. We have a YouTube channel where we have previous webinars which you can easily get to. So everybody will get an email who has attended today with those links, a link to the slides. So you'll have all the information hopefully that you need, and obviously come back to us if you want to evaluate any of the software that we've shown today. So thanks everybody. Have a great day, and we'll hopefully speak to you soon. Thank you again.